Hello everyone, welcome back to my channel codeWithKhan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem. 868 binary gap, easy marked. So given a positive integer n, find and return the longest distance between any two adjacent ones in the binary representation of the n. So if there are no adjacent ones, so we'll just return the 0. Two ones are adjacent if there are only 0 separating them, possibly none. So you can have 1, 1 also. The distance between two ones is the absolute difference between their bit positions. For example, the two ones in this 1 0 0 1 have a distance of 3. How? So if we mark their indexes, we are seeing 1 at 3 and the index 0, so 3 minus 0 is 3, so it has distance of 3. Okay, let's see the constraints. So n can be up to 10 to the power of 9. Got it? Okay, now let's see one example how we can solve this, how we can approach. So for example, we have 1 0 1 1 0. Okay, what we'll do is we'll start iterating from the end, right? So there are multiple approaches for this. Either you can convert this into a binary string using two binary string method. So you can use this method and convert it into a string, and then you can do the traversal on string also. So we can check the difference between the two ones, and we can update the max length every time by converting into string. But we now we will see a approach where we can solve it without converting it into a string also. Okay, what we'll do is, so I have explained you how to get a last bit, right? How we can get a last bit. So if we do AND operation with 1 to any integer, it returns the last bit of that number, right? For example, in this scenario, we have n is equals to 22 as 1 0 1 0 1. If we do AND with 1, it will return 0 0 0, so which is 0. So last bit of this n is 0. So like that we can retrieve the last bit of any integer n. Got it? Now what we'll do is, so we will take two variables. One is last index, which is used to store the last seen one index. So initially it would be 0 because we haven't seen any ones till now. Then we'll use current index to calculate the indexes. Okay, it will be initially 0. So what we'll do is we'll traverse from right to left. So it is fine either you traverse from left to right, or you can traverse from right to left, right? So the distance would be same, right? From here to here the distance is same, and from here to here is also distance is same. So what we'll do, we'll traverse from left to right, and each time we will get the last bit, and we will check if if it is 1, we'll check if you have seen 1 before. If you have seen, we will find its difference, I mean the distance. Otherwise we'll update. If you are seeing 1 for the first time, we'll update the last index. Got it? Now let's see, do a dry run. 1 0 1 1 0. Okay, current we'll take another variable called max length to store the max length. Initially it would be 0 again. So what we'll do is we'll start from here. Current index is 0. Now we will get the last bit. So last bit is 0 now. So if it is 0, what we'll do, we'll just update the index. We'll proceed further. So we come to here. So the current index is 1 now. So now what is the last bit? So what we need to do is every time we will remove the last bit. So we no longer need this bit, right? So we'll remove this. So now we can get last bit using n and 1. So now what is the last bit? Last bit is 1. So now we have seen 1. So now we will check if you have seen once before. No, right? Because last index is still -1. So we are seeing 1 for the first time. So what we'll do, we'll just update the last index and we'll proceed further. So I will update the last index because I have seen at current index 1. So I will update the last index to 1, and then I will proceed further. So now it comes here. I will just remove this bit. Now current index is 2, and what is the last bit? Using n and 1, we will get the bit as 1. So now we have seen 1 again. So did we see 1 before? Yes, we have seen 1 at last index 1. So current index is 2. So how we can find the max length? So we can find the max length. So max length is equals to max of max length comma, so we can get the distance. We'll just do the current index minus last seen index. Okay, so if we do, we'll get the max length. So what is the max length currently? Which is max length is initially 0 and current index is 2, last index is 1, so it would be 1. So we'll update the max length with 1. Now what we'll do, we will proceed further. We'll update the current index to 3 and we'll update the last index to 2 because we have seen one further, right? Now I would remove this one also. Now we'll get the last bit. So now last bit is 0, so is this is not 1, so we'll just proceed further and I will update the current index to 4. Now we come here, I will remove this bit also. Now we'll get the last bit using n and 1. So now we got the last bit as 1. So did we see 1 previously? Yes, we have seen 1 previously, right? Last index at index 2. So and we are currently standing at index 4. Now what we'll do, so since we have seen 1 before, we'll just update the max length. Max length will be initially it is 1 and now current index is 4 and last index is 2. Now it is 1 comma 4 minus 2, which is 2, and the maximum is 2. So we'll just update the max length and we'll proceed further and we'll go to index 5 and n will become 0, empty, right? We have nothing. So if we'll only loop till n is greater than 0. So and we found the max length as 2. We'll just return this max length. Got it? Now let's write pseudocode for this one. So what we'll do, we'll take two variables as I mentioned, last index as -1 and current index as 0 and max length as 0. Got it? We'll take these three variables and we will iterate till n is greater than 0. Okay, now we will get the last bit, right? Int bit is equals to n and 1. So we got the last bit. Now what we'll do, we need to check if this bit is double equals to our 1. So if it is 1, what we'll do, we'll check if you have seen 1 previously, how we can check that if our last index is not equals to -1, that means we have seen that before. If it is not equals to -1, then we'll update the max length with math dot max of max length comma current index minus last index. Okay, if we are seeing that for the first time, right, if we are seeing that for the first time, then we'll just update the last index. Then last index is going to be current index. So we can write this outside else condition also, because every time we have to update the last index, right? So we'll write this here itself. So last index is equals to current index. Okay, this is fine. So if bit is 1, then we have to do this. If otherwise in else condition, we will just do, if it is 0, then we will just update the current index, and then every time what we need to do, we need to remove a bit. So we'll do n redshift of 1 bit. N is equals to n redshift of 1 bit. Got it? And at the end we'll just return max length. Got it? Okay. Now what is the time complexity for this one? So the time complexity is going to be, so as I previously mentioned, for each n we need to require at least log n of bits. So we'll use so we are iterating, since that we are iterating log n time. So time complexity big of n, and space complexity we are not using any data structure, so it would be big of 1. Okay, now let's write code for this. Let's take the variables first. We'll take int last index to store the last seen 1. I will initialize it -1 first, and I will take current index as 0, and then one more variable to store the max length is equals to, initially it would be also 0. Now we'll use a while loop and we'll iterate till n is greater than 0. And then first condition is we'll need to fetch the last bit into bit is equals to. Now we need to get n, and once it returns the last bit, I will check if bit is double equals to 1. Then what we need to check if you have seen the last index or not. So if last index is not equals to -1, that means we have seen 1 previously. So what we'll do, we'll just update the max length. So max length is going to be math dot max of max length comma, now we find the distance current index minus last index. Okay, now if we are seeing 1 for the first time, and we need to update last index every time whenever we see the 1, so it would be current index, last index is equals to current index. And other condition, if bit is 0, then if it is bit is 0 or bit is 1, every time we need to update the current index. So I will just update the current index plus plus, and every time we need to remove 1 bit, so n is equals to n right shift of 1. So every time we are updating the current index and we are updating the we are removing the last bit, and at the end we'll just return the max length. Okay, now let's execute this code. Yeah, it is accepted. Let's submit this now. Yeah, it is accepted with 0 milliseconds runtime. If you like my content, please do like, share and subscribe. Thank you.